Okay, this is problem 85 from chapter 6. I'll read it a little bit for you. We have a pump that's required to pump 800 kilograms of water per minute from a well that's 14 meters deep, and it's supposed to eject it out at 18 meters per second. There's three parts to this. The first part, part A, is asking how much work is done per minute to lift the water out. So we'll do that part first. This is part A. We need to find the work done. This one is pretty simple. All we need to do is do our mass times gravity times the height. So we have 800 times 9.8 times our 14 meters down. That's going to give us 109.8. This is kilojoules per minute. So to find the work done, we just plugged in. We took our 800 times our gravity times the distance. It gives us 109.8 kilojoules per minute. That's the work required. How much work is done in a minute to lift the water. B says how much work is done in giving the water the kinetic energy it has when ejected. So B, we're going to use a kinetic energy equation. Which is our 1/2 mv squared. Hopefully fuzzy. So kinetic energy is 1/2 our 800 times our velocity squared. And that comes out to 129.6 kilojoules per minute. I should write minute. Just show that for you. We get 129.6 kilojoules per minute for the kinetic energy. And last, what must be the power output of the pump? So we're going to this is part C. We're going to say T for the total work, total power output, which is just, So we're going to take our first one, which was 109.8 plus 129.6, and we're going to divide it all by 60 because we're going to want this in per second. Kind of see this, but it comes out to 239.4 divided by 60, and that equals 3.99 kilojoules per second. So the total power output, we just added our total energy together, divided by 60, so that we didn't have minutes anymore. And we get 3.99 kilojoules per second as the total power output. And that's it.